You know that feeling? You type print, parentheses, hello world, hit run, and boom. It just appears. It feels instant, almost like magic. But what's actually happening under the hood? Well, that's what we're going to unpack today. We're going to follow your little line of Python code on its secret journey from your screen to the computer's brain.
But first, before we get into all the technical stuff, let's bust a super common myth. When you hear the word Python, I bet the first thing you picture is a big snake, right? Most people do. But that's not actually where the name comes from.
Yeah, seriously, it has nothing to do with snakes. The guy who created Python, Guido van Rossum, was just a huge fan of the British comedy show Monty Python's Flying Circus. He wanted a name that was short, a little weird, and unique. And Python just stuck.
So, putting the name aside, what is Python really? Well, you can think of it as a translator. It's what we call a high-level language, which is just a fancy way of saying it's designed to be easy for us humans to read and write. We give it instructions in something that looks kind of like English, and Python does the hard work of turning that into something the machine can actually execute. So, you ready to see how it works? Let's follow a piece of code. It all starts with you, the programmer, typing out an instruction. This is literally the birth of your program, the very first step of its big adventure. And that text you write? That's got a name, source code. It's the set of instructions you type into a file that ends in .py, just like our classic print hello world. It's the blueprint, the raw ingredients for everything that's about to happen. You just save these instructions in a plain old text file, something like hello.py. This little file right here is the hero of our story. We're going to follow it every step of the way, from this simple document to a running program.
Okay, so you hit run. Now, you probably guessed the computer just reads your Py file directly, right? Nope. There's a really important kind of magical step in the middle. Let's talk about something called bytecode. Your code doesn't get translated straight into the raw ones and zeros that a computer's processor understands. Python is a bit more clever than that. It uses an intermediate language to make things way more flexible and efficient. And that language is bytecode. Your human-readable source code gets compiled into this stuff. You can think of it as a set of instructions that are not quite for the processor, but are perfectly understood by another part of Python. It's a universal language for Python itself. And you can actually see this happen. Your hello.py file gets turned into a hello.pyc file. That C at the end, it stands for compiled. This new file is what holds all that bytecode we were just talking about. So why do this? What's the point? Speed. That's the main reason. Python cleverly saves these .pyc files in a special folder called _pycache. That way, the next time you run your program, Python can just say, hey, I've already compiled this, and skip right to the bytecode, making your program start up way faster. All right, so we have our bytecode sitting in a .pyc file. But it can't run on its own. It needs a special environment to execute it and bring it to life. And that's where the Python virtual machine, or PVM, enters the picture. The Python virtual machine is the real engine of the whole operation. It's basically a program that acts like a computer inside your computer. Its one and only job is to understand and run Python bytecode. It's the final translator in our journey. So, the PVM grabs that .pyc file, reads the bytecode instructions one by one, and tells your actual computer hardware what to do. This is the moment it all comes together. The PVM's work is what finally makes Hello World actually appear on your screen. So, now that we've seen all the individual parts, let's zoom out and put the whole puzzle together. Seeing the full picture really helps understand what makes Python so special and so powerful. Let's do a quick recap of the entire journey. First, you write your ideas as source code in a .py file. Then, Python's compiler steps in and turns that into efficient bytecode. That bytecode then gets fed to the Python virtual machine, which interprets it and finally produces your output. Simple, right? This whole process brings up a classic debate, a question that programmers love to argue about. Based on what we've seen, would you say Python is a compiled language or an interpreted one? What do you think? And the answer is, it's both. It's kind of a trick question. Your Python code is compiled first into bytecode, but then that bytecode is interpreted by the Python virtual machine. This clever hybrid approach is one of Python's secret superpowers. So why does this two-step process matter to you? Well, two big reasons. First, as we saw, caching that compiled bytecode in .pyc files makes your programs run faster. And second, it makes Python incredibly portable, because any computer that can run the Python virtual machine can run your bytecode no matter what. You can write your code on a Mac, and it'll run just fine on a Windows or Linux machine.
So there you have it, the secret journey of your Python code, from a simple line of text to a fully running program. Now that you know the magic behind the curtain, you have a much deeper understanding of the tool you're using. So the only question left is, what amazing thing are you going to build with it? Go for it.